Hello guys, welcome back to my YouTube channel. Today we are going to solve day 20 problem of this month on LeetCode. If you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started. So today we have easy problem. So in this problem we have given an array nums containing n distinct numbers in the range 0 to n, and we have to return the only number in the range that is missing from the array. Okay, so today I'm going to solve this problem using two approaches. One is XOR and one is simple maths. Okay, so now let's see how we are going to solve this question using a simple math approach. Okay, so let me copy this example. So this is the first example given to us. Okay, so here you know what is the sum of numbers in what is the formula for the sum of numbers. Okay, so in maths sum of n numbers is n plus n into n plus 1 divided by 2. Okay, so this is the formula in maths that we use to calculate the sum of first n numbers. Okay, sum of first n numbers. So let's say we have to calculate the sum for numbers 1 2 3 1 2 3. Okay, or you can say 0. So 0 doesn't have any significance here. So 1 to 3, let's say we have to calculate the sum. Okay, 1 to 3. So what is the total sum? 1 plus 2 plus 3. So what's the total sum here? 3 plus 2 5 plus 1 6. Okay, can I get the same answer, that is 6, using my this maths formula? So let's see. So here I have to calculate the result till 3. So total numbers are 3 here. Okay, so can I write it like this? 3 into 3 plus 1, that is 4, divided by 2. So 3 into 4 is nothing but 12, divided by 2, that is 6. So I get the same answer. Okay, 6 here and 6 here. Let's calculate the sum of first 5 numbers. Okay, so first 5 numbers, 1 plus 2. Okay, let me start here from 0. Okay, I'm going to show you one more thing. 1 plus 2 plus 3 plus 4 plus 5. So what is the total sum here? Okay, so here you are ignoring this 0 now, because 0 doesn't have any significance when I am adding this. So I can write it like this, right? So what is the sum of 5 numbers? These 5 numbers: 5 plus 4 9, 9 plus 3 12, 13 14 15. Okay, so 15 is the sum. So let me write 15 here. So 15 is the sum. Can I get the same answer using my maths formula? So let me use it. So total numbers are 5. So n is nothing but the number of total numbers. So total number 5. Sum of first n numbers we are calculating. Okay, sum of first n numbers. So when my n is 5, so I have to write like this: 5 into 5 plus 1, that is nothing but 6, divided by 2. So 5 into 6 is nothing but 30. Okay, 30 divided by 2 is nothing but 15. Okay, so I get the same formula, same answer, 15 15. Okay, so this is the maths approach, okay, that we are going to use. So here in this nums array there are total 3 numbers. Okay, total 3 numbers. Okay, here explanation n is equal to 3, since there are 3 numbers. 3 numbers are there. Okay, so now when I calculate the sum of all these numbers, then what is going to be my output? So I'm calculating the sum like this: sum of 3 numbers is nothing but 3 into n plus 1, that is 4, divided by 2. So my output is nothing but 6. Okay, when I am going to subtract this 6, okay, now what I am going to do, I am going to subtract this 6 this is a total, this is the expected sum of the first three numbers. This is the expected sum. Now from this expected sum I am going to minus the sum that I am getting from this array. So what is the sum that I am getting from this array? 3 plus 0 plus 1, I am getting 4. So when I am subtracting this expected total sum with the sum that I am getting from this array, I am getting the result as 2. Okay, and this 2 is going to be the output because this 2 is the missing. Okay, so I hope that you guys are clear. So this is one more example, 0 to 1. So 0 to 1, 0 to 1, how many total numbers are there? Total numbers are there 2. Okay, what is the sum of first n numbers? Sum of first n numbers is nothing but 2 into 3, that is 2 plus 1 divided by 2. So here I get the output as 3. Now I subtract this 3, that is the expected sum with the sum that I am getting from this particular array, that is 2. So 3 minus 2, 3 is the expected sum, 2 is the sum that I am getting from array. So I am getting the output as 1, right? No, sorry, here it's not 2, it's 1 now. So array sum is 1, not 2. 0 plus 1, 1. So 3 minus 1 is 2. So here what is the output that I am getting? 2. So 2 is the missing number in this particular array. I hope that you guys are clear. Okay, so this is one maths approach. So now let me write the code for this, just 4 to 5 lines. Okay, and yeah, one more thing. So here for this problem, space complexity is 0, 1, and runtime complexity is also of O and n. So we are following this conditions. Okay, so we are using one particular this fixed n variable nums dot length. Okay, so for this space complexity is of 1, and also in total this is the expected sum for the first 10 numbers. So I told you that we calculate the expected sum as n into n plus 1 divided by 2. This is how we calculated the expected sum. Okay, so for this variable also space complexity is 1 because the value is fixed. Then after that sum, I have initialized sum as 0, so space complexity is still 1, and then time complexity is going to be n because I am going to go over all the elements to calculate the sum. For I is equal to 0 and I is less than n, I plus plus, sum is equal to sum plus the array's element the present, okay, at particular index. So this is how I am calculating the sum, and in the end I have to return expected sum, that is my total, right, minus the sum that I am getting from the array. So let me run it. So all the test cases has been passed. So now let's submit it. Okay, so our solution is accepted, and it beats 100% of users with Java, right? So now let's try to solve this problem using XOR method. Okay, so let me review the submission notes. Okay, so here now we are going to solve this question using XOR method. Okay, but before solving this problem with XOR, you have to know few properties, okay, of XOR. So first property is that XOR operation is commutative and associative. Okay, so what does it mean? So it means that the order of operands doesn't affect the result. You can group operands in any way. Okay, so for example, A XOR B XOR C. Okay, this is equivalent to C XOR B XOR A. Okay, so the order doesn't matter here. Okay, so XOR operation is commutative and associative, and this property allows us to XOR all the elements in the array, okay, and all the indices together without worrying about the order. Okay, and second property is XORing a number with itself results in 0. One second. Second property is XORing a number with itself will always result in 0. Okay, so this is how XOR operation works. Okay, so 1 XOR 0 is 1. 0 XOR 1 is 1, and 1 XOR 1 is 0, and 0 XOR 0 is also 0. Okay, so these are the XOR operations. So XORing a number with itself will always result in 0. Okay, so let's say we have this number given to us. Let's say 3 is given to us. So 3 in bits, I am going to write 3 like this: 1 2 3 4. Okay, so I am going to write 3 like this: 1 2 4 8. Okay, so I am going to write 3 like this: 1 1 0 0. Okay, this is how I am going to writing 3. Okay, so when I XOR this 3 with itself, so again I write 3 here. So what is the total output? 1 1 is nothing but 0, 1 1 is nothing but 0, 0 0 0 0. So total result is 0 only. Okay, so XORing a number with itself will always result in a 0. Okay, these are the bits. These are the 1 2 4 8. These 2 raised to power 0, 2 raised to power 1. So I hope that you guys are clear with this. 2 2 2 4. Okay, so here I am XORing a number. Now see one more thing here. So let's say this is the input given to us. Okay, so here, okay, so this is, so let's say for this particular array there are total 3 numbers. So can I write like this? Like for this, let's say if all the elements are present in my nums, so let's say 3 0 1 and 2, all the elements are present in my array right now. Okay, so this is a new example in which all the elements are present, and how I am going to represent these elements based on the indexes. So this 3 is at 0 index, this 0 is at 1 index, this 1 is at 2 index, and this 2 is at 3 index, right? So here when I am going to XOR, I am going to apply XOR operation between number and their index. Okay, so I am going to apply XOR between their number and their index. So 0 0. Okay, so here I am going to apply 0 XOR this 3. Okay, so 0, here I am writing 0 XOR 3. After that I am also applying XOR of next index, that is 1, with the next number, XOR 0. Okay, then so see here, this is my next index and this index. So I am XORing everything, every element and every index right now in my result. Okay, so this is what I am doing. Then after that XOR index 2 element 1, XOR index 3 index 3 element 2. Okay, so now here in this particular array all the elements are present now, all the elements are present. So here one thing is clear, this 0 is appearing, this 0 is appearing 2 times, this 1 is appearing 2 times, this 2 is appearing 2 times, this 3 is appearing 2 times. So if all the elements are appearing twice, then simply means that the result is going to be 0. The result is going to be 0. Okay, since 0, I can write, I have told you that this XOR operation is commutative and associative, so I can write it like this: 0 XOR 0 XOR 1 XOR 1, right? I'm going to I can write it like this, but for all these the output is 0 XOR, for here this 1 XOR 1 output is 0. So total output I am going to get 0, because here one more thing here, and the number index. Okay, here I think I have mentioned XORing a number with itself will always result in 0. Okay, so here when all the elements are present in my array, then I am going to get the output as 0 only, nothing. Okay, so all the elements are present, there is no missing element. But in this particular example 301, let's say I write it like this: 3 0 1, and what are the indexes for this one? This is 0th index, this is 1th index, this is 2nd index. Now I am going to store the result. I am going to store the result for all the indices, because in the end, in the last example, I am getting the result by XORing all the numbers now. So let me store the result for particular indices one by one. So result is equal to result is equal to result XOR the particular index. Okay, this is one thing that I'm going to do. Then after that I'm going to get the one result. Then after that, in the result I am going to XOR the result with result XOR the elements that is present. Okay, this is what I am going to do now. So just see this property. Okay, so here what is my n is 3, n is 3. So let's say, let me store this result value as 3 initially. Okay, result is equal to 3. Okay, result is 3. Let's say result is 3. So now first I am going to result is 3. Initially I have taken the result as 3. So let's say 3 is the missing element. 3 is the missing element, let's say. So I am taking n as n is 3, because total number of elements 3, and result I stored 3. So to say that, let's say 3 is the missing element. So now after that I did what? 3 XOR I is initially 0. Okay, I is initially 0. So 3 XOR 0, what is 3 XOR 0? So 3 XOR 0 we are going to check. So one second, let me erase here everything. Okay, so now what is 3 XOR I? This is these two steps we are going to perform. Okay, so here I am writing 3 XOR I, that is 0, is nothing but, so let's write it in bits. So these are the bits: 1 2 4 8. Okay, so 3 is representing like this in bits, and 0 is represented like this in bits. So 3 XOR 3 is nothing but 3 only, right? This is the output that I am getting. So 3 XOR 3 is 3. Then after that I am going here in the result. This is second step. Result is equal to 3. My result is 3 right now, and XOR it with the nums of I. So nums of I is 3. So 3 XOR 3 is nothing but 0. because two duplicate elements, right? These elements are 2 times, so we have to return 0. XORing a number with itself will always result in 0. I have already explained that. Okay, so here my new result becomes 0. Now in the next step, when my I becomes 1, so here now my result becomes 0, right, from last step. So 0 XOR with the index 1. So 0 XOR 1 is nothing but 1 only, right? So 1 is represented like this, 0 0 0 1 and 0. So here I get the output as 0 0 1 1 only. So now my result becomes 1. So here now my new result is 1 XOR nums of I, element at index 1, that is 0. So 1 XOR 1 is also 1. Okay, so this is clear. So now my I reaches at this index 2. So result is 1 from the last step, 1 XOR index, that is 2. So let's do 1 XOR 2. So 1 is represented like this, 0 0 0 1, and 2 is represented like this, 0 0 1 0. Okay, so my output is going to be 3 0 0 1 1. Okay, so I hope this is clear. This is 1, this is 2. So when I apply XOR, so output is 0 0 1 1. So I get 3. Okay, so now result becomes 3. So here comes new step, 3 XOR nums element at index 2, that is 1. 3 XOR 1 is nothing but, so let's write 3 here, 0 0 1 1, this is 3, and 1 XOR it with 1, 0 0 1 0. So output is nothing with XOR with 1 is the element. So here is 0 0 1, not 0 0 1 0. So 0 0 1. Okay, so output is 0 1 0 0. So output is nothing but 2. Only 1 bit is set here, so output is 2. So this is my result, right? 2 is the output. So now this 3 cancel out with this 3. Okay, this 3 cancel out with this 3, because in the initially I assumed that result is 3. So this result 3 is cancelled out with this 3. This 0 is cancelled out with this 0. This 1 is cancelled out with this 1. But we are left with 2. So that is the only output. So this is how XOR is working. Okay, so code is very simple for this one. Very, very simple. Okay, so let's write the code. So same way, int n is equal to nums dot length. Then we are going to initialize the result to n, which represents the last number in the sequence. Okay, so int result is equal to n. Space complexity is 1 and time complexity is going to be of n. Okay, for this approach as well. Now we are going to XOR all the indices and numbers. So I am going to run one loop for int I is equal to 0, I less than n, I plus plus. Okay, and after that result, in the result we are storing everything now. So result is equal to result XOR with the index XOR with the nums of I, right? And in the end we are just going to return the result. That's it, single one line result, return result. Okay, we are going to return this result. Now let's submit it, our code, and see how much runtime it is taking. Okay, let's see. So solution is accepted and runtime is still 0 milliseconds and it beats 100% of users with Java. So I hope that you guys are clear with both the approaches that I have explained today. And if you guys still have any questions, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Thank you. Bye bye. Meet you in the next video.